Alright, here are solutions to perfect problem 4 for Math 251. This is the trig one, so you're asked to prove the following facts. You're supposed to use the product rule, the quotient rule, and really you're only supposed to know two derivatives. That the derivative of sine is cosine, and the derivative of cosine is negative sine. And with that information, we can come up with the derivative of any of our other four trig functions. For example, you could figure out the derivative of secant. It turns out it's secant times tangent. And the way we'll do this, and we'll say, okay, the derivative of secant's the same as 1 over cosine. And now we can use the quotient rule. Let's see, if you want, the quotient rule says that the derivative of the quotient f over g is f prime g minus g prime f over g squared. To use some shorthand here, f and g are both functions of x, I guess in this case. So we can apply this formula on this quotient here. The f in this case, maybe I'll move this over a little bit. The f would just be 1, and the g is cosine of x. And those are two functions whose derivative we know. The derivative of a constant is just 0. Derivative of cosine is negative sine. So if we plug in these values into this formula, we get that the derivative of 1 over cosine is f prime g, so 0 times cosine of x, minus g prime times f. So g prime is negative sine of x. Let's see, how do I write this? How about like this? Negative sine of x times 1. And that's all divided by g squared. G is cosine. Alright, so we got cosine of x squared, which you can write like this. And now we just try to simplify this. Let's see, 0 times anything, this is 0, negative, negative, those cancel out. So what we got is sine of x over cosine squared of x is the derivative of secant. It wants us to show that that's equal to secant times tangent, so hopefully this is equal to secant times tangent. The way we can show that is we can say, okay, sine over cosine squared is the same as sine over cosine times cosine. And I can write it like this. And sine over cosine is tangent, 1 over cosine is secant. So what we have here is secant of x times tangent of x. Turn the TV down a little bit. Second one, kind of the same idea. Maybe I'll go a little bit quicker. We're trying to find the derivative of cosecant, okay? Cosecant is equal to 1 over sine. So if we're going to use our quotient rule, we have f is 1, g is sine of x, f prime is 0, g prime derivative of sine is cosine. We apply our quotient rule and get f prime times g minus g prime times f divided by g squared. And kind of same idea, 0 minus, okay, so what we got here is negative cosine of x over sine of x times 1 over sine of x, because sine squared is sine times sine. And what we have here is cotangent, what we have here is cosecant. So this is equal to negative cosecant of x times cotangent of x. Alright, third one. Figure out this derivative, but don't use the chain rule. This is a problem that's kind of tailor-made for the chain rule, but we are only supposed to use the product rule and the quotient rule. Alright. Quotient rule informally says that if you're trying to take the derivative of a product of functions, what you do is you take the derivative of the first one multiplied by the second one, and then add to that the derivative of the second one multiplied by the first one. So this doesn't really look like a product rule question, but we can rewrite it in a form that makes it a product rule question. E to the 2x plus 1 is e to the x plus 1. Yeah, 2x is x plus x. Now we can get a little bit clever and use an exponent rule. If I have the same base what I do is I add up the exponents. So I have the same base in all three of these that I'm multiplying together. So what I do is add up the exponents. I'd get x plus 1, what I have over here. In other words, e to the x plus 1 is equal to e to the x times e to the x times e to the 1. It turns out that's a derivative we can take. E to the 1 is just a constant, e. So we can pull that out in front. And what we have to do is take the derivative of e to the x times e to the x. And now it looks a little bit more like the product rule. F is equal to e to the x. G is equal to e to the x. F prime is equal to e to the x. G prime also e to the x. So what I want to do here is apply the product rule here. Let's see, f prime times g, e to the x times e to the x, plus g prime times f, e to the x times e to the x. And what this is equal to, e to the x times e to the x is e to the 2x. And so I have one of these e to the 2x things plus another one of these e to the 2x things. I have two of these e to the 2x things. Starting to run into myself here. That wasn't great. What I have here is 2. E times e to the 2x, I have the same base, so I can add the exponents. This is e to the 1, this is e to the 2x, so I get e to the 2x plus 1. So what I have is the derivative of e to the 2x plus 1 is equal to 2 e to the 2x plus 1 using the product rule. Part 2, do these exact same things but now use the chain rule. Okay, the good news is the chain rule is a little bit quicker. Chain rule, I'm trying to take the derivative of secant, but I recognize that secant is 1 over cosine, which I could write as cosine of x raised up to the negative 1 power. And then my outside function is this negative 1. Leave cosine of x alone. Subtract, we're going to use power rule here. So negative 1 minus 1 is negative 2. But then I'm not done. I have to multiply that by the derivative of the inside function, this cosine of x. So what I get is negative 1 cosine of x to the negative 2. See, derivative of cosine is negative sign. And then this is a negative and a negative makes a positive. Something to the negative 2 power is the same as squaring it on the bottom of the fraction. And as we saw earlier, this here is equal to secant times tangent. All right, let's do it again. So this one we're asked to find the derivative, or show that the derivative of cosecant is this guy, but again using the chain rule. The way we'll use the chain rule is we'll say cosecant is the same as sine of x raised up to the negative 1 power. Taking this derivative, we use the chain rule. My outside function is x to the negative 1 power. Use the power rule on that to bring the negative 1 down in front. Leave sine of x alone. Subtract 1 from the negative 1 to get negative 2 here. Then you're not done. You still have to multiply by the derivative of the inside function, sine of x. Alright, negative 1 sine of x to the negative 2. The derivative of sine is cosine. So what I get is this is equal to negative cosine of x over sine squared of x, which, as we saw in earlier, is equal to negative cosecant of x times cotangent of x. We proved that in part B of question 1. And finally, the last one, this guy here. This is the one that's most suited for the chain rule, in my opinion. The derivative of e to the 2x plus 1, e to the x is just e to the x. So the derivative of e to the 2x plus 1 is e to the 2x plus 1 takes care of the e to the x function, but we're not done. We still have to multiply by the derivative of the inside function, which is 2x plus 1. Derivative of 2x plus 1 is 2. So what I get is e to the 2x plus 1 times 2, which we can write as 2e to the 2x plus 1, which is the same thing we got in number 1. So good that we got all the right answers. We got them in 2 different ways. So I guess that's the end of this perfect problem.